Okay, welcome to 4.5 and 4.6 and this little tiny thing in between, which they just kind of tuck in there, a little 4.5 extension. All right, this is a nice continuation of what we did last time. Last time we did SAS and SSS as ways to prove triangles are congruent. So if you ever have to prove in a proof that you've got a triangle congruent to a triangle, which happens a lot here in the unit where the title is triangle congruence. We talked in class about how most proofs either end with this or they end with another step that has to do with CPCTC. Anyway, when you're trying to justify why triangles are congruent, the only things that can go there are SSS, SAS, or these three we learned today, and that's going to be the end of that list. This is what we're talking about, what can possibly go there. Okay, so let's get on with it. The first one is ASA, uses the same naming convention that we're used to, where angles and sides are named thus. And ASA is called that because, again, it's the side, just like SAS, it's a side between two angles, or it's, two angles and the side in between them. And that's this tightly packed collection that we're talking about. So if it was angle A and angle C in this triangle, if this and this in this triangle were congruent to the same kind of stuff in another triangle, what would we need to complete ASA? Well, we would need AC to make angle side angle. If, next example, if it were angle A and angle B, like that, we would need side AB in this triangle to be congruent to the similar kind of thing in another triangle to complete angle side angle. Okay, this one's pretty easy. It's symmetrical. In other words, like the side is between two angles, it's the two angles and the side that connects them. It's pretty easy to spot. It's a postulate, so we can't really ask why. We just have to take it on faith, sort of. I have that GSP demo I can show you, but this one, it's pretty easy to believe. Okay, then here comes another one. It's the first one that's actually a theorem, and it's AAS, which is two angles and the side that's not between them, or a side that's not between them. So here we have AAS. That side is not included. The trickiest part about that, first of all, why is this a theorem and not a postulate? This is not hard to believe, or this is not hard to prove. If we knew that and that and that were congruent to that and that and that in another triangle, and if you didn't have this AAS congruence, you'd be like, oh, you know what? With two angles of this triangle congruent to two angles of this triangle, we could actually easily use the third angle theorem and say, well, that one's true. And now we have ASA, the one we just learned above. So this is just a shortcut for not having to do exactly this. We just can say AAS. It's a shortcut for, third angle with ASA. But that's why it's a theorem and not a postulate. It's the only one that we've seen so far that is a theorem and not a postulate. The trickiest part about this is this little statement right here. If you have AAS, you have to worry a little bit, because this is the first naming, in all the stuff we've had so far. And again, we're completing this list today. It's the first one that's not symmetrical, you notice. So we got to be careful about something. If I had angle, angle, side in this triangle, congruent to, let's say angle, angle, side in this triangle, this would not work. This is not AAS. Even though it looks like angle, angle, side and angle, angle, side, it's not the same angle, angle, side, right? The side here is kind of coming off of the two-tick angle, and here's coming off the one-tick angle. Or maybe a better way to think about that is this side is opposite the one-tick angle, and this side is opposite the two-tick angle. So you kind of have to keep track. This is not okay. When you're trying to do AAS, again, it's not symmetrical. They do it correctly up here, so that's good. But you got to make sure that the non-included side is corresponding, like it's the correct one. It's actually easier than it sounds, but that is a concern that's new. Okay, so here's the four of them. The book does this nicely. It gives you all four of them in the same place here. This is a picture of all four of them, just to see what we've done so far. But then, for whatever reason, the book's like, oh yeah, there's this other one that they stick in this 4.5 extension kind of piece. Like this, they had this little kind of like one-page supplement section in the book between their 4.5 and their 4.6, and it's kind of important. It's kind of a big deal that there's one called HL. So actually HL is going to complete the list here of all the ways that we're going to say that triangles are congruent. It's kind of a big deal. Okay, so HL, why is it so different than all the others? Well, the problem is, or the difference is, that now we're just talking about right triangles. So maybe that's why they treat it like a little auxiliary kind of reason. But if we're in a right triangle, this side that we say is opposite the right angle, we call that a hypotenuse. And the hypotenuse is one of the things that's congruent here. And the other thing is one of the other sides, and that's called a leg in a right triangle. So there's actually three things, even though there's only two letters there. There's the idea that it's a right triangle, so that's important. And then these other two things, which is the hypotenuse and the leg. Technically speaking, if you're going to label that stuff in a right triangle, there's a leg, there's a hypotenuse, you consider that to be like side-side angle, and side-side angle isn't a thing, as we've talked about. But what's special about right triangles, as you may have heard before, there's this thing called the Pythagorean theorem. So if you knew these two sides, if you knew two sides of a right triangle were congruent to two sides of another right triangle, you could actually figure out what this third side is going to be, or that third side really isn't ambiguous anymore because there's a Pythagorean theorem around that would solve for that thing, whatever it is. And so now it's basically equivalent to side, side, side. You don't have to know that. That is why it's a theorem and not a postulate, because it is provable, just not by the stuff we've done so far this year in Excel math. Okay, so HL is the thing. HL, yeah, can only work for right triangles, but the danger is people see two right triangles congruent, or some problem about right triangles, and they're like, okay, that's got to be HL. Well, wait a second, it doesn't have to be HL. Like, we used to do stuff like this, that's fine. This would still be SAS. Like, that doesn't have to be HL just because it's a right triangle. So, yeah, HL can only apply to right triangles, but right triangles can be congruent for other reasons that aren't necessarily HL. Okay, problems in a box. This is everyone's favorite. Okay, are these two triangles congruent and why? You can see that there's Sketchpad does these angle measures a little bit hard, so they're kind of hard to see because I don't know, it's almost like, are they labeling this whole thing? Are they labeling half of it? Like, what's going on? Yeah, they're labeling half of it. I kind of wish they would do something like this, but yeah, those two sets of angles are congruent. Yeah, and we have reflexive here. If this was a proof, you have to list reflexive, and now we have ASA, so this is yes, and this is triangle A, let's say ABD. If it's ABD, just be careful that has to be the same. It's not CDB, it's not twisted. B goes with B and D goes with D. Here we have another angle set here with vertical angles. And in one of my blocks today, someone said, you know what, that means we actually have third angles. Yeah, that's true. And so now it kind of looks like we have angle, side, angle marked here, and angle, side, angle marked here, or we have AAS marked in both places. Just be careful. Those don't correspond. Even though we know about all three angles and we have a side, there's no set. There's no way to find an ASA here or an AAS. I guess that'd be the only ones you'd be tempted to think about because there's no two sides, right? So it's just those two. There's no set of this, either one of those, that corresponds and lines up between those two triangles. So this is not enough info, actually. That's kind of a tricky one. All right, this one, again, vertical angles here, but there's no sides at all. All of the reasons have some kind of side length. It could be that these things look kind of more like this, and they would have all the same angles, but they don't have any sides that line up. So yeah, we don't know about this one. So don't be afraid of the nose. It's kind of interesting that there's two no's on this thing, but it can happen. So test taking strategy would tell you that this is probably going to be yes after two no's. And you'd be right. Yep, we've had this before where there's this reflexive business here, and now we do actually have HL. These are right triangles, and these are the hypotenusi, and the other thing shared is a leg, so we have hypotenuse leg. So A and B is similar to C and B. Again, it's not twisted. M goes with M, B goes with B. All right, so here's just some technique, strategy stuff about proofs. I've been all year I've been saying, or all year I guess, about proofs. I've been saying, there's things about proofs where there's some strategies, like if you know what the last thing is, sometimes it makes sense to think about what has to come right before that, or once you're given the given, there's some things that have to be immediately harvested from that, like midpoint or bisector. But now as we're getting into more complicated proofs, we've got way more things, very quickly we're starting to get way more sophisticated kind of menu items of things to choose from for what could make things congruent, or what kind of proofs we could be asked to do. So yeah, this is just some hints. Don't forget about vertical angles. Don't forget about reflexive kind of things. Don't forget about all the fun rule stuff. And of course this stuff I just talked about with midpoints or bisectors. This is a nice hint to remember to label angles with numbers, just because they're easier for everyone to follow if you do that. Hopefully they're already numbered in the diagram, but if not, there you go. Oh, also I forgot to talk about this. Mark the diagram with any given information and mark stuff as you go. The danger with this is don't mark the stuff until you've got it taken care of here. Like, make sure you list it and then go ahead and, mark it in the diagram. Don't mark it in the diagram first. That's very tempting, because it's like, oh yeah, I see these angles are congruent, and I see these angles congruent, blah, blah, blah. And then you forget to put it here, and then you get through the proof and it's not there and you miss points because you have to label it here also. So I would only mark it in the diagram after you've got it in the proof. Yeah, and of course, again, if it's a triangle congruent to triangle step, it has to be one of those 5 things there. And again, this is the triangle congruent to triangle kind of unit. That's what this whole unit's about. Either the proof will end with this step, or it will have one more step, and that step is probably going to be CPCTC. CPCTC, yeah, I did that right. CPCTC has to come after a triangle step. So yeah, these are super important. Those have to go here. CPCTC is only going to happen after a triangle congruent, so triangle congruence, again, is the name of the unit. So you should find those. Here's a whole bunch of proofs we're going to practice. Great. All right, 1 is congruent to 4. I could mark that. That's given. I would never ask you to fill this in. And 2 is congruent to 3. Okay, so we are going to be asked eventually to prove these things are congruent. These proofs where, half the thing is filled in and half the thing is, reasons you have to supply, they're kind of getting harder because it's getting harder to follow someone else's story, because there's so many ways things could go, and there's so many possibilities for reasons and steps. So again, when this is on a quiz or a test, I will always put in the directions, like, you can also do your own. You don't have to do the one that's suggested here. All right, so yeah, the thing that has to go here has to be something like SSS or SAS or ASA. If this is on the board, I would point to it, but here it is. So one of those things has to go here. The other thing is, as soon as you list one of these, like say we were going to list, I don't know, AAS, that's wrong. But if we were going to list AAS, just make sure that the angle, ooh, that's cool, and the angle and the side, those ingredients all have to be listed somewhere up here in the proof before we can say that it works here. Okay. All right, so which one is it? Those are just hints to help you think about, like, what might go here. Because honestly, reflexive property, that could be about anything. You could say angle B is congruent to angle B, reflexive property. Like, okay, that's right, but is that helpful for this? Okay, we'll see. All right, so maybe it's helpful to think about this first. And honestly, if we're looking at this picture, and you think about all those questions we've already done with problems in a box, it's probably pretty easy. Like, you look at these two things and like, oh yeah, I've got two angles already. This is either going to be angle side angle or angle side. I can tell looking at the picture that that's what I need. Oh, and it's reflexive. I'm already talking about reflexive here, so stop talking and just do the thing. Right, it's obviously ASA, right? But I think you kind of have to look at the whole thing in context. You kind of have to look at the end of the proof before you can figure out what that is, or what that's asking for as the reflexive step. Okay, angle A is congruent to angle C. Again, I'd never ask about this first thing. I'm kind of cheating here. BM is perpendicular to AC. By saying perpendicular here, I would count that as an angle. Like, I wouldn't actually say, oh, well, then angle 1 is congruent to angle 2. Excuse me. I don't think that's actually necessary. We're not going to grade you on that, or we're not going to require that when we assign the points. By virtue of perpendicular, that counts as the angles being congruent. I think that's good enough. Okay, this is one where we're just asked to prove that triangles are congruent, so that's nice. But again, right away, I don't know what rule goes here, but I know it's one of the 5, right? It's got to be SSS, SAS, blah, blah, blah. All right. So looking at the diagram so far, we already have an angle and an angle in both triangles. So it's probably angle, angle, side, or angle, side, angle. I mean, I'm trying to kind of focus your attention and think about remaining possibilities, right? So it's either angle, angle, side. So in this whole diagram, I'm looking to see, is there some other side that might be congruent? And yeah, of course, it's this thing right here. So that would be angle, angle, side. If I say that MB is congruent to itself by reflexive, then I'm done. We've got everything there. Everything's marked. Okay. All right, here's one where what they're asking me to prove is not about triangles being congruent. These last two, it was about triangle congruent to triangle, triangle congruent to triangle. Okay, if it's not triangle congruent to triangle, here's a hint. It's probably that the last step, this thing is going to be CPCTC, just by title of the unit. Now, as we go through the year, that's not always going to be quite so obvious, but honestly, Unit 2, triangle congruence proof unit, this is what it's about. So if that's CPCTC, this is going to have to be some triangle congruent to some triangle, and oh yeah, it has to be because it's an ASA thing. All right, and it's going to have to be a triangle where AD in one triangle is lining up with BC in the other triangle. So, okay, let me go back to the beginning. AM is congruent to BM. I didn't really even do this. And angle A is congruent to angle B. I kind of wish they would have just said angle 1 and angle 2 here. That M is kind of not really great. So there we go. I've got ASA already marked in these triangles, so I think this is going to be kind of self-explanatory, but let me write these reasons in first. This is given. 1 is congruent to 2 because of vertical. So yeah, all those reasons from Unit 1 are still around. This, the fun rule, angle bisector, it's all there. Now all I got to do is just be careful to label these in a way that they line up. M goes with M, and C goes with D. So hopefully A, wait a second, B, M, oh gosh, I did that wrong. A, M, D, here D's over here, right? A, M, D, and B, M, C, yeah. So here, yeah, A, D, and B, C still line up in those two triangles. Okay, great. I like that. All right, but again, following someone else's story and being able to fill in reasons when it's like this, like, might be harder than doing your own. You can totally do your own. Your own probably would have turned out this way, but sometimes it's easier to even just like see that and act that out completely on your own. You might go try to do your own and say, oh, I don't get that, I'm going to do my own. And then do your own and come back and look at this and go, oh, that's exactly the same. That's totally fine. There's nothing wrong with that. Okay. Whoa, wrong thing. Given PR bisects. Oh, I want to say this right now. If that's a bisector, let's just do this. Angle 1 is congruent to angle 2. We've been doing this since Unit 1. Definition of angle bisector. Okay. This is given. Given all this stuff, and that was the bisector thing, and PQ is congruent to PS. All right. So